Well, UCM, uniform circular motion. What do you mean by uniform circular motion? So it can be defined as a body said to be under uniform circular motion when it moves on a circumference of a circular path of fixed radius with constant speed. Again, it must have a circular path of fixed radius with constant speeds. How to understand this one? So here, if you recall the discussions that motion in a straight line or linear motions, you have the accelerations due to rate of change of speed, because motion in a straight line, the direction is not changing, it's not changing, it's unidirectional, and there the acceleration is only because of change of speed. But here the speed remaining constant, we can think of a system where the body is circulating on a fixed circular path of fixed radius with constant speed it is rotating. So in that case, the direction of the body at each point of time, I mean the direction of the velocity, if you say, changing each point of time. If you see to that of your figure 1, I have shown the 4 selected directions tangentially, that is upward directions, downward directions of y-axis, similarly positive x-axis and a negative x-axis. These are the 4 directions I have shown in figure 1. But in fact, the body possesses infinitely many directions throughout entire course of its travel. Now, this is a case of uniform circular motions where you have accelerations, and such accelerations is always towards the center. So therefore, we will be saying that as centripetal accelerations. So this is a case of motion on a plane. Unlike the case of motion in a straight line where you have linear accelerations, here you will have centripetal accelerations. Now, to understand this concept of centripetal accelerations, we will use 2 important discussions of mathematics. Number 1, that circle is nothing but a polygon having infinitely many sides. What I say? Circle is a polygon having infinite number of sides. That is the first one. You can imagine polygon having n number of sides where n tends to infinite. That is the first concept we will be using here. The second one is that the closest pair of points on any curve represents the line segment. The closest pair of points on any curve, of course nonlinear curve, always represent line segment, means it is a linear one. Line segment, it is a linear one. These 2 concepts we will be discussing throughout these discussions. So let us proceed to find out what is centripetal accelerations. Now, if you see to figure 2, that I have picked up the position P and P prime are the 2 selected positions where the body possesses velocity v and v prime respectively, and Cp being the radius vector and Cp prime is the r prime radius vectors. Angle subtended by these 2 radius vector r and r prime is delta theta. Now what happens? You can say that here by triangle law of vector addition, the r vector here and the r prime vector here will lead to, it will give rise to p prime are the delta r as the change in radial vectors or change in radius vectors, you can say. Now what happens in figure 3, the delta theta is exceedingly small. I have reduced the point p prime very close, that we are using the concept of mathematics that 2 points are the closest point. So therefore we will assume that between p and p prime, in between p and p prime, there is no other point. That means p prime are the closest pair of point on this curve p prime. So in that case, we can always think that p prime becomes, that p prime arcs becomes a line segment, as we have discussed, because the closest pair of point on any curve is nothing but a line segment. So p prime is now a line segment. So now what will happen? Next we will consider the figure 4, where CP prime will generate a triangle with angle subtended between the radius vectors, that is CP and CP prime is delta theta, which is of course limitingly small, exceedingly small, and delta r is the resultant between them. In the same way, the tangents drawn to these p and p point, p prime, here p prime are closest points, so therefore the tangent drawn to these 2 points will be treated as PMN. So I have in figure 5, that is PMN is the corresponding triangle, where this triangle we have formed out of PM being the velocity at P point and Pn is the V prime, that is the velocity at P prime. So therefore we can write here it is velocity V and this is V prime, giving that Mn becoming the delta V. Now if that is the case, we can consider figure 4 and 5 and check that the triangle CPP prime and triangle PMN, where is PMN, these two triangles, here of course this is the triangle, these two triangles are similar. It is because the angle subtended between them is same, delta theta here and delta theta here. So as for the SAS, side angle side, both these triangles are similar. If that is the case, then between these two similar triangles we can take the ratio, that is PP prime, that is PP prime divided by Mn, that is PP prime by Mn must be equal to Cp divided by Pm. This is Cp and this is Pm, and all these are line segments. It is line segments and magnitude we are only considering. It is one of the geometrical approach we are trying to get the magnitude. Okay. Now here in place of P prime we can substitute, this is P prime, in place of that we can substitute the values as delta r, this is delta r, and in place of Mn, that is nothing but delta V. So therefore P prime line segment by Mn line segment ratio will give us delta r by delta V, and in the right hand side we will have Cp line segment by Pm line segment will give rise to ratio of r by V. If that is the case, then we will have delta V to that side becomes V by r into delta r. Now this is the case that we are getting the velocity difference, or we can say the resultant velocity Mn to be V by R into delta R. Now if we imagine that the limiting case is such that delta theta tends to 0, which happens when delta t tends to exceedingly small. That means taking the limit delta t tends to 0 of ratio delta V by delta t. That means this expression we divide both sides. In the denominator we divide it, that is delta t. This side also we delta t we divide. Our objective is to find out the acceleration here. So therefore the definition of acceleration is this one. This is the definition of accelerations. Definition. This is the definitions of acceleration, isn't it? So therefore acceleration, which we have seen as the limiting case of delta t tends to 0, delta v by delta t, here v by r being constant, we take it outside and take the limit delta t delta r upon delta t. So therefore this is again the definition of, what? V. Velocity is defined as rate of change of speed, we have seen. So here delta r, I mean the velocity, or you can say V is nothing but limit delta t tends to 0, delta r by delta t. If you substitute here, it becomes acceleration, which we say AC, centripetal accelerations, because it is not the case of linear accelerations. So therefore we use a script to identify. So centripetal accelerations, which is nothing but v square by r. So this is how the magnitude part of the acceleration. Now coming to the direction part of the centripetal accelerations, if you carefully see that each time the Mn, which we found out of the resultant of the v and v prime vectors, that is the resultant vector delta v, is always towards the center, or you can say it is exactly parallel to Cp, or in other words you can think of that somewhere here, if you join, delta v is always perpendicular to the delta r. Delta v vectors is always perpendicular to delta r vectors. So therefore this is the delta r vector and this is delta v vectors, they are perpendicular. So therefore the direction of acceleration, centripetal acceleration of course, is always towards the center. That is how we say it, center seeking acceleration or center seeking force. So this is how we think of uniform circular motions, and the point you need to remember here is that the body must follow a circular path of fixed radius. The radius must be fixed, it should have a constant speed, and during the course of derivations you have to keep in mind that we are using the concept of circle as a polygon having infinite number of sides, because we have used here P prime as a line segments. So unless you imagine that one, you cannot take P prime as a line segment, and in fact this is the beginning point of Newtonian mechanics. You can derive the same centripetal acceleration using the derivative principles, and that is the same case of getting the acceleration in a calculus method. So there is no question of assuming an approximation here. So in fact P prime are the two closest point. In between these two closest point, no other point can be found out. Using this, you can imagine these two C P prime and PMN are two similar triangles, and take the case of SAS theorem in geometry to apply to find out the ratio and get an expression for delta V equal to V by R into delta R, and then apply the definition of acceleration after dividing delta T throughout. In getting the definition of acceleration, you must apply delta T tends to 0. So this is all about uniform circular motion. This is one of the important discussion in motion on a plane. As we have seen one such case as of motion in a plane in our previous discussion, that is projectile motion. We will see our next discussions more about this. Thank you.